A kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of string has been let out? We'll start by sketching a diagram. This vertical distance will represent the 100 feet above the ground. And our kite string is this diagonal. We can label the horizontal as x, the angle as theta, and we'll label the string as z. Other information that we are given, we know that the horizontal speed is changing at 8 feet per second. That is dx dt, 8. d theta dt is what we're looking for, specifically when the string, or z, is 200 feet long. Up next, we need to create an equation. This time, since we're involving the angle, we need to use a trig function. And it looks like we need to use opposite over adjacent, tangent. Tangent of theta equals the opposite 100 over the adjacent x. One common mistake students make in this kind of problem is they might try to use z, but we don't want to use z because we do not have dz dt. We do have dx dt, and we know what the opposite is. So we're using tangent due to the fact that we know dx dt. Up next, I'm going to rearrange this tangent equation to isolate the x. So cross multiply, we get x tangent theta equals 100. Dividing by tangent, x is 100 over tangent. And then x we can think of as 100 times cotangent theta. This is just a little bit easier to take the derivative of rather than taking the derivative of the original. So implicitly differentiate both sides. The derivative of x is 1 times dx dt. The derivative of 100 cotangent theta is negative 100 cosecant squared theta d theta dt. So we first need to divide by negative 100, or we can think of that as multiplying by the reciprocal, negative 1 over 100. And we need to divide by cosecant squared theta, or we can think of that as multiplying by sine squared theta. From here, we'll plug in what we know. Negative 1 over 100 times dx dt, which we are told is 8. Sine squared theta we have to think about in a moment. And d theta dt is just what we're looking for. So to find sine squared theta, we need to think about what's happening with the string z. When z is equal to 200 from the given information, what is sine of theta? Sine of theta is opposite over hypotenuse, or 1/2. And don't forget that we need to square that. So plugging this into the calculator, we get that d theta dt is negative 1 over 50 radians per second.